Okay, so in this video we're going to be talking about units. And the first thing I want to do is I want to go over what are the units for distance / displacement. What are the units for speed and velocity? What are the units for acceleration? And what are the units for time? Okay, so I'm going to actually go ahead and erase, just because I wrote that so spaced out. I'm going to rewrite this distance and displacement. And then we're going to start with distance and displacement. So let's try to write that just a bit neater. Okay, so the units for distance and displacement. In this class, we're mainly going to use meters. Okay, meters are a unit of length, right? Okay, length or position or height, right? Meters. So distance and displacement are measured in meters. Speed and velocity are measured in meters per second. Acceleration is measured in meters per second squared. Otherwise, otherwise known as meters per second per second. Okay. And time is written in seconds. Okay. So in this class, we will be using a particular system of units. You will notice, right, that meters aren't the only way to measure distance or displacement. Seconds is not the only way to measure time. And because of that, meters per second and meters per second squared are not the only ways to measure speed and acceleration. Right, so for example, I could have, written here, oops, got my eraser out. I could have written feet, right, instead of meters. Or I could have written hours instead of seconds. And then my speed might become feet per hour. Okay, and then my acceleration would become, feet per hour squared. And that would be fine. But we're going to go by what's called the MKS. Oops. Sorry. Let me recenter my screen there. But we're going by what's called the MKS. So MKS. And it's called the MKS because the fundamental units are meters, kilograms, and seconds. We haven't got to mass yet, so we haven't talked about kilograms, but we will eventually. So right now, what I want you to notice, though, is when I say fundamental units, I mean everything in our class is going to be expressed in either meters, kilograms, or seconds, or some combination of meters, kilograms, and seconds. And you can already see this being true, right? So distance and displacement are expressed in meters, and time is expressed in seconds, but speed, velocity, and acceleration are expressed in a combination of meters and seconds. Okay, so everything in this class can be broken down into units-wise, meters, kilograms, and seconds. Right? That's why we call this the MKS system. There are other systems out there. This is just the one we're going to use. Okay, so I want to show you now a little bit about how to manipulate units during a problem. So units can be treated like a variable, right? So, and what I mean by that is, we're familiar if we have x times, x squared divided by x to the fifth, right? If you were given this and asked to simplify it, right? Hopefully you remember from math from last year, well, when we have x times x squared, we add the exponents, that becomes an x cubed. And then when we divide, we subtract off exponents, so this would become overall x to the negative 2. Now, very similarly, if I wrote seconds times seconds squared over seconds to the fifth, if some problem had led me to make this multiplication and division, I would treat these seconds as if it was one variable. So seconds times seconds squared, I would just increase, I add the exponent, so that would become seconds cubed over seconds to the fifth, which is equal to seconds to the negative 2. Okay. So maybe a little bit easier to see if I just wrote it as s, right? So the same math holds for variables and for units. Okay, and this is really convenient for us, right? Because it means we know how to handle, and let's put one of our equations out there. It means we know how to handle something like VF squared equals V naught squared plus 2 times A times D. Okay, so we know, right, if we were just going to do this in units, right, that we know that velocity has units of meters per second, right, from what I just said, and that's squared. We know even though its initial velocity has the same units as velocity, meters per second, and we square it because that's what the equation says to do, plus 2 times, well, we know acceleration is meters per second squared, and we know distance is meters. Okay, so now what I'm going to show you is that in all of our equations, anytime we add or subtract, our units have to line up. Okay, so what I mean by that is all terms, right? Terms will hopefully we'll remember that from math, but terms are things kind of in between our addition and subtraction. So in this case, I've got 3 terms. All terms in this equation have to have matching units. If they don't, we don't have a valid physics equation. So we're going to check that right now. I've already written, right, this equation with our units. So let's go ahead and do a little bit of math and make sure that these units do indeed match. So if I have a meter per second, I square the whole thing. That becomes metered squared per second squared. Okay, that's the same over here, meter squared per second squared. So far, so good. And now we just have this last term, and let's make sure it matches. Well, 2 doesn't actually have any units, right? So actually I can kind of, if we're just trying to match units, this is unitless. So I can kind of drop that out. And here we have meter per second squared times a meter. Well, we add the exponents, right? That just is, each of those has exponent 1, so meters squared per second squared. And indeed, our units do match up. Okay. So this can give us a lot of, clues to problems. Because if our units don't match up, then, we've done something wrong. And it can also tell us, if we know the units of something we're trying to find, we know that, hey, if I've been given something in meters per second squared, I know that's an acceleration, right? If I've been given something in meters per second, I know it's a velocity. If I've been given something in meters, I know it's a displacement or a distance. And if I've been given something in seconds, I know it's a time. So units can be very, very, very powerful. And, to be very precise with our questions, let's write out guess here. If we were given a question that gave us initial velocity was 5 meters per second, final velocity was 10 meters per second, and time was 2, and we were looking for distance, 2 seconds, right? We could figure out, and I'm kind of shortcutting this a little bit, but our equation here is distance is equal to v naught plus vf over 2 times t. And, because I've done these problems so many times, and you'll eventually be able to see this, we can double check our units here. If I put a meter per second plus, here, let's do this in units. I'm going to switch to green. If distance, I need to get meters, right? Because that's what my units of distance are in. And if I have a meter per second here plus a meter per second, right? 2 times a second. Well, we know 2 is unitless, so it doesn't matter. A meter per second plus a meter per second still is a meter per second. And finally, when we have a second divided by a second, that cancels out. So we have meters equals meters. So this is kind of a roundabout way of saying the equations I've given you, if you use, right, the MKS system, right, all of your equations will work out, right, unit-wise. So if that feels a little bit, you're not so convinced by this explanation, then I encourage you, when you're doing your questions, to keep units in the problem as you're solving, right? Like this, instead of just writing the numbers. And this would solve out to be ooh, sorry. This would solve out to be 15 meters. And we can see, I kept units in the equation and they did indeed work out. Okay. So, yeah, you have a couple of options. One is to be convinced that, if I'm using MKS system and I have all my units in the given right and I have all my units in my unknown correct, then these equations will indeed work out. Now, that means, right, if for some reason, instead of, using meters per second, for some reason I was given an equation in feet per hour, then this whole thing will be wrong because it's not in the MKS. And